As we continue on to topic 1.6 of chapter 1, we're going to give you a general review of equations. And it's sort of important to know the steps needed to solve equations, so I've listed them here. And again, put this in your notes, because I said on the test, if you write these steps out, sort of like this, in this order, I can give you 5 extra points. So that's sort of a good deal. So what are the steps? Step 1 is if we look at an equation and we see that it has fractions, we want to get rid of those fractions, whether they're decimal fractions or the regular fractions. And we do so by multiplying each term by the least common denominator. And when we have an example like that, I'll bring that to your attention. Another item, remove grouping symbols. Usually it's a parenthesis. Sometimes it might be a division bar, or there may be others, but you get rid of those. Now you just have individual terms with plus and minus, so to go to step 3, combine like terms. So after you combine like terms, you're going to have, let's say, something like 3x plus 2 equals x minus 6. So you'll have a variable, a term, equals a variable, a term. So now there are no more like terms to combine. You're ready to go into the next step, which we're calling to transpose, so that all the variables are on one side, all of the numbers are on the other. Then, when you end up, let's just do that. If this goes to this side, this becomes 2x minus 8. We're transposing, and we'll go through it in more detail. And then you isolate the variable, the x, by dividing by the number that's with the variable. This is called the numerical coefficient of x. And you get x equals negative 4. And then that's your solution. So we'll go through that in some detail as we do these examples, but these are the steps used in solving equations. Another thing is you want to try to keep your equal signs lined up and show your work in the steps clearly. Okay, we can erase this and start in with number 9. Well, let's do 1 through 6 is vocabulary. And again, read the statement. You've had the lesson. You want to be able to match those up or put that in. Vocabulary with the statement. Number 7 and 8, they're asking if the equations are equivalent or not. And there's one that is and one that's not. And you're going to determine that. Is what's on one side as an equation, does that equal the other? If they do, then they are equivalent. If not, they're not. Okay, so here's one that we're starting with. It already has decimals. And in this case, we're not going to bother getting rid of the decimals. But if it were complicated, we would. Here we want to isolate the x by itself. So in order to do so, I have to add something to a negative 3.1 to make it a 0. And we're going to add its additive inverse, which is a positive 3.1. And in order to keep it equivalent, we have to do it to both sides. So remember, an equation is sort of like a scale where you want it to balance. You're just taking things or adding things so it stays balanced, but eventually you can get an x all by itself. So here, these cancel out, and we're just left with an x. and then this becomes a 7.8, and then that's the solution. For number 10, again, there's just a variable equals a term, but we want to find out what n is. So when we have a number that's with a letter, this is called the numerical coefficient. In order to get the n by itself, we divide by that numerical coefficient. They cancel out, we get n equals -7. Now in number 11, again, we have a -8 here that we want to get rid of because we want to get the t's by themselves. So I'm going to add 8 to both sides. I get here a 27. 3t equals 27. And then again, to isolate the t by itself, I'm going to divide by the numerical coefficient, which is a 3, and I get t equals 9. So in example 12, we see we are going to use our first step of clearing fractions. And what's our common denominator here? Well, it's 2. So we have to multiply every term by 2. And then here the 2's cancel out. So now there's no fraction there. So this becomes 4x plus x equals 40. I now combine like terms. This becomes 5x equals 40. I divide both sides by 5. X equals 8. Notice it's sequential, equal signs sort of line up, and there's your solution. In number 13, we have to get rid of parentheses, so we distribute. We get 2x minus 10 equals 14. Now we want to get rid of the -10, so we're going to add 10 to it. This then gives me, these cancel out, I get 2x equals 24. I'm going to divide by 2. X equals 12. Here we want to clear parentheses, so we have 16 equals 6y minus 30. Have to be careful of the signs, and it never hurts to check your work. Now I'm going to add 30 to both sides, and I get 6x equals 46. Now I'm going to divide both sides by 6. I get x. And notice I can take a 2 out of each one of these. So this will reduce to 23 thirds. And that's the answer. And when you get an answer like that, leave it as an improper fraction. Don't change it to a mixed number. In example 15, notice we have a parenthesis. So we want to clear the parenthesis, and this goes back to earlier sections. When you have a negative in front of a parenthesis, you remove it by just changing the signs of the terms inside the parenthesis. So this one was positive, this will become a negative. This was negative, this will become a positive. And a technique we had earlier, for getting rid of a parenthesis that has a negative sign in front. So now we're going to combine like terms. This is going to give us a 4x plus 5 equals 37. I'm going to subtract 5 from both sides. That's going to give me a 32. Yep. And you might say, well, I didn't write that step. Well, as you go on and you improve your skill, you will be taking shortcuts. And let me also introduce this term again, transpose, where we take a term from one side of the equation, bring it over to the other side, and as we bring it over to the other side, cross the equal sign, the sign changes. So I had 37 minus 5. Mentally, I got a 32. And now I'm going to divide both sides by 4 mentally, and I get x equals 8. And again, you might say, well, I didn't show that I'm dividing. As you progress, you can cut down on the steps. But again, you want to be sure you get the right answer, and if you need to write that step, go ahead. For number 16, we're going to combine like terms first. So here we have a 9m and a 2m, which will give me 11m. Then we have a 6m and a negative 1m. That'll give me a 5m. And notice after combining like terms, this is a stage you often want to get to, that you have a variable, a term, a variable, a term. And then now you're going to transpose, and I'm going to bring the 5m over to this side as a negative 5m, so that leaves me with a 6m. I'm going to bring this negative 3 over, and that will be a positive 3 on this side, which leaves me with a negative 6. Again, I'm cutting down on steps. If you want to review the steps, go back in the tape where we've done them in more detail. But this is, as you progress, you want to cut down on steps. So transposing changes the sign, 6m becomes a positive 3, that divide both sides by 6, m equals negative 1. And again, as you put these in practice, or the quiz bee, you're going to see if you have mastered the skill. All right, at number 17, we have fractions. Now this is a term, this is a term, this is a term. And I'm going to change colors. What will be my least common denominator here? And the answer is 15. So I'm going to multiply each term by 15. Now when I do so, this goes into there once, 5 times. I have to multiply that once, 3 times. Now I'm going to get rid of parentheses, but remember I have a 5. 5 times 2n is 10n. 5 times a negative 5 is a negative 25. 3 times 15 is 45. And I have, to get rid of this parenthesis, I have a 3 times 2 outside. It's going to make that a 6. 3 times 2 makes that 6. So this then becomes a 6n plus 24. And again, never hurts to check your work. Multiply every term by 15. 3 goes into there 5 times. Nothing cancels there. 5 goes into there 3 times. So this, in a sense, becomes a 5 here. 5 times these give me this. 3 times 15 gives me that. 2 times 3 gives me the 6 that I will then distribute, and I get that. All right, next step is to combine like terms. So I have 10n, and I have a minus 15 and a positive 45, minus 25 and a positive 45. That's going to give me a positive 20. So now again, I have a variable, a term, a variable, a term. I'm going to transpose. This comes over here as a negative 6, so this becomes a 4n. This goes over here as a negative 20. 20 minus 20 will give me a 4. And now I divide both sides by 4. I get n equals 1. You can always rewind the tape or play it again. You want to try to do these on your own too. And if you need the backup, this is your reference. Now they do get a little more tedious as we go on. Here we see we have brackets. Let me double check that. Yes. So what we do is what's in the bracket first. So we're going to go 2, 6, get rid of the inner parentheses. This is going to be a negative 3x plus 15 equals 10 minus 4x minus 24. So we're distributing. We still have to get rid of this, so this is going to be a 6 and a 15, that's going to be a 21. So let's just do that, 21 minus 3x here, times 2. So this will be 42 minus 6x equals a negative 4x, and let's combine this into a negative 14. So checking out everything, I think we're in good shape. Okay, so we want our x's to be positive. So I'm going to transpose this. This is going to become a 2x over here. Positive 6x, and this is going to become a negative 14 on this side, positive 14, so this becomes 56. And then we're going to divide by 2, and this is going to be x is 28. Yep. Okay, for this one, 5x minus 7, combine this becomes 5x plus 2. I see something special is going to happen here. I'm going to subtract 5x from both sides. I then get negative 7 equals 2. Is this a true statement? And the answer is no. Therefore, in this equation, this is a contradiction, and there is no solution. Or the answer is an empty set, or you can write it that way, or no solution. However you want. Okay? This is the answer they give in the book. So here we want to get rid of parentheses. We distribute. Now we want to collect like terms. And for number 20, you see what we have here is an identity. So if we subtracted 6x from both sides and subtracted 3 from both sides, we would get 0 equals 0. Even though initially it didn't look like it was an identity, when we went through the process of solving an equation, this is what we end up with. So our answer for number 20 is an identity is all real numbers. So this is 6x plus 12 equals 4x plus 12. We transpose the 4x. This gives us a 2x. We subtract 12 from both sides. That gives us a 0. We divide both sides by 2. X equals 0. Now remember, x equals 0, don't get it confused with this. Here it was 0 equals 0. Here they're saying x equals 0. That's a good answer. In fact, if we put a 0 in there, then this becomes 2 times 6 is 12. And a 0 there, 4 times 3 is 12. Yeah. If 0 is a good answer for that x, makes it a true statement. This one's just a little tedious. Let's work it out. We do the innermost parentheses first. So this becomes 4 minus 2 plus x. And then change all the signs. So let's just do that. This is going to become a negative, this is going to become a positive, and this is going to become a negative. Because that was a positive, and then we're changing the signs again. And then there's now a 3 there. And then all of this is going to be times 2. So we can kind of combine like terms. 3 and 2 is 5, minus 4 is a 1. So this becomes a 1 minus x. Now, times 2, this becomes 2 minus 2x equals 1 minus 4x. We want our x's to be positive, so I'm going to transpose the 4x. Becomes a positive 4x, and a negative 2x is 2x. This becomes a 2 over this side, a negative 2. This becomes a negative 1. Divide both sides by 2. X equals negative 1/2. And I don't get that answer, so let's check it here for a moment. All right, we're going to go along with that one. What happened is when I copied it down, I didn't copy it exactly the way it was in the booklet. But that's a good example, too. As we do these next items, we're solving for letters here. And I have a special video on YouTube that just deals with letters. But these are the ones in our book. And we're going to use the same steps for solving an equation. But now we want to solve for the letter M. So we're going to divide by x. The x's cancel out. And our answer then is M equals y over x. Here we're going to solve for the letter R. Again, going to divide both sides by qx. R equals s divided by qx. Now we want to solve for n. So it's a fraction, so we're going to multiply both sides by s squared. Here the s squareds cancel out, and I get n equals s squared t. We did a lot of these in class as well, but if you're absent, this is how it's done. And when you see an equation where you're solving for a letter, kind of take a moment to look at it and get the lay of the land, so to speak. We want to solve for t, so we want to get this term on the other side. And we're going to transpose. So it's going to be v minus 2x, because we're transposing this to the other side, equals 20t. And then you just divide by 20. T equals this. And transposing is a very good technique as you're solving for c. I have the 2c. The f is there. I'm going to transpose these other two. So that becomes a minus 2d. And a minus e. And now all I have to do is divide by the 2, and there's my answer. Now if you put the 2 over each term, you could do some canceling, but that's what they're asking in the book for this one. There is a shortcut here, but let me just show you the regular way. We want to get rid of the fraction r. So we multiply both sides by r. The r's now cancel out, and I get Rn equals a plus b. But I want to solve for r, so I'm going to divide now both sides by n. And that's what r equals. The shortcut is when you see something like this, you could reverse the letters, but that may be, the regular way is probably better. Okay, winding this up, we want to solve for b. So we're going to multiply both sides by c. Here the c's cancel out. And now I want to get rid of the a. Well, let's see. Yeah, I'm going to get rid of the a. And this will be cd minus a equals a negative b. So in order to make this a positive b, I'm going to divide everything by a negative 1. There may be another way to do this, but this way's all right. And this becomes a negative CD plus A equals B. So the book probably has it B equals A minus CD, but it's the same. All right, this is an extra one that I'm doing. I want to solve for the letter B. And as we do this, we want to multiply every term by the lowest common denominator, which is going to be A, B, C, A, B, C, A, B, C. So here the A's cancel out, here the B's cancel out, and here the C's cancel out. So now I'm left with BC plus AC equals AB. Now notice I want to solve for B. And I have a B on this side and a B on that side. So I have to move all the B's to one side. So I'm going to transpose that to the other side and get a negative BC. So I now have AC equals AB minus BC. Now here's the case, and we had one like this in class, where we have two letters that are in different terms. Got a B here and a B here. I got to get that B out of those. I want to isolate the B. And an earlier lesson we had factoring, where we factor out the B and get A minus C. And that's AC. So whenever you have a letter that's in two terms that you have to solve for, you factor it out. And now we're just going to divide by A minus C, and that's what B equals. B equals AC over A minus C. This is a very common example that's used on tests. Well, again, you're going to work on your practice, mastery, as you prepare for the test. My strong advice, don't leave it to the last minute. Get the practice so that when you come for the test, you are confident in your skills.